Assalamualaikum and hello to Prof. Matia Dr. Syamsul Aizam bin Zulkifli. My name is Muhammad Fairuz bin Muhammad Noor. My card metric number is DE20095. So in this video, our team will explain about PID controller design for speed control system. So this our group member, Muhammad Badrul Amin, Muhammad Ikram Daniel, Muhammad Fairuz, me, and Muhammad Afiq. So we go to the introduction. At the introduction, a proportional integral derivative PID controller is an automatically optimized and precise control system that is used to maintain desired value for various parameters such as temperature, pressure, and speed. And next, control loop feedback is the basic technique employed in PID controller. Next, PID are used to regulate the heat supply and ensure that the overall effect of all operation is commercially and economically viable. Next, proportional is used to determine the difference between the desired and actual value as well as the remedial response. And the last is the integral term is used to determine all previous error values and then integrate them to find the integral term. And we go to the PID controller. So the PID is P is proportional, I is integral, and D is a derivative. So the proportional, integral, and derivative value are calculated using the error value, which is continuously monitored by the PID controller. And the output is then created by adding these three values together. For the first is proportional. The proportional is multiplying the P gain by the mistake yields the proportional. The proportional goal is to have a large rapid response on the output in order to bring the process value closer to the set point. And for the integral is calculated by multiplying the I gain by the error, then multiplying that by the controller's cycle times. And for derivative is obtained by multiplying the D gain by the process values RAM rate. So we go to DC motor. At the DC motor is a machine that transform electrical energy into mechanical energy. So the input electrical energy of a DC motor is direct current, which is convert into mechanical rotation. So this a part for construction for DC motor. We have shaft and armature conductor, and this a commutator, and it's a interpole, and is a field winding, and behind the end we have a pole show, and the whole circle is a yoke or frame.
Hi, my name is Muhammad Ikram Daniel. My metric number DE2056. So at my first turn, I will study for you about our problem statement. As we know, our problem statement has three main points, which are to design the PID control system for controlling the speed of the blade with a motor DC as an actuator. So for the first point, we design a mathematical modeling and block diagram for motor and a blade as a load, and then we implement the block diagram for the system by using MATLAB Simulink, and we run the system for input speed equal to 900 rpm and output speed is 1500 rpm. For the second problem statement, which is to determine PID gain of this project. For this main point, we create the control system block diagram for manual turning PID controller on MATLAB Simulink by applying P, PI, and PID controller by using PID gain. And then we create the system block diagram for automatic fine tuning PID controller on MATLAB Simulink. So the last one for problem statement is to compare manual and automatic turning of PID controller. And the description for the number 3 is we plot the comparison between the manual and the automatic turning of PID controller response. We observe the minimum or the maximum overshoot, time rise, setting time, peak time, and steady state error. So I pleasure my friend to further the presentation for problem execution.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Badrul Amin bin Hamidan with metric number DE20042. I will continue our group presentation for the part of problem execution. Okay, first of all, as we can see on the slide beside me, we need to know what is PID controller. We need to know each equation of P, equation of I, and equation of D, so that we can combine the equation and then it will become like on the slide combination of PID equation. Okay, we will continue to the modeling of DC motor with PID controller for the system in a construct for the block diagram, which is has a sum part for part of P, I and D, and then we'll also have another sum, and then the PID will plan or process, and then it will has its own output. Okay, and then I will go through to the graph calculation. We need to know the value of L, T, and K for the graph, and then we can calculate the value of KP, KI, and KD. Which is KP, we need to know what is the values of A, and then we need to find A is equal to K times L over T, and then we can find the values of KP. For the value of KI, we need to know when we get the value of KP, we need to divide with the value of TI, which is TI is equal to 2 times L from the graph, and then we can get the answer for the KI, and then the last is for KD. KD is equal to KP times TD. TD is equal to L over 2. Okay, that's it for the graph calculation, and then I will proceed to the part of implement of the system in MATLAB Simuli. Okay, there have two types of block diagram, which are first is open loop circuit of DC motor, and then the second one is a closed loop system with PID controller, as we can see on the slide. Okay, that's all for me. I will pass to my friend Muhammad Afiq to continue our presentation for the discussion and results. Thank you.
Okay, for the next is which is result and discussion. The circuit below shows the performance of open loop DC motor. Next is this is the response graph with input speed 900 rpm. This is the response graph with input speed 1500 rpm. So from this graph you can see that the output speed is it is not reach the maximum power for the speed, because the speed given is 900 rpm, so it just reached to 700 rpm. Same goes to the 1500 rpm. It does not go to the 1500 rpm, but it less than 1500 rpm. So the circuit below shows for modeling of DC motor with PID controller. And this is the input speed graph response for P controller. And this is for PI controller. And this is for PID controller with input speed 900 rpm. So this is the input speed 1500 graph response for P controller. Next is for graph response for PI controller, and lastly is graph response for PID controller. So from this graph, as we can see, from 900 RPM, the graph goes to the maximum power. Okay, so even if the input speed is different, the form of graph is practically identical when the same sort of controller is used to operate DC motor. So Kp for P controller is 250. Although large number of Kp is employed to get the output speed as close to the required speed as possible, steady state error and overshoot will occur in the response. So MATLAB Simulink allows user to employ automatic tuning for the PID controller in order to obtain precise and perfect coefficient values for Kp, Ki and Kd. When opposed to manual tuning, automatic tuning can produce superior response because manual tuning is trial and error procedure can be difficult to discover the ideal coefficient for Kp, Ki and Kd. Okay, I think that's all from me.
So for the conclusion, PID is a simple control technique and easy to understand the structure. In addition, only first order unstable process can be stabilized with a P controller. For PI controller, it can be employed to minimize the major disruption and the noise. And for PID controller, it might be employed. So what can we say? PID control are commonly used in industry. In a nutshell, we are able to test the open loop system using MATLAB Simulink. We are also able to design a P, PI and PID controller for a closed loop system. Last but not least, by this project, as a student, we are able to perform well in teamwork. Having soft conversation and effective discussion through Google Meet is not simple as we imagine it, but we go through it very well. I believe we can easily learn something new if we work together as a team. So that's all from us. Thank you.